In today's presentation, we are going to learn how to classify slope according to its value. When we're done with today's lesson, you'll be able to identify slope by its picture as to whether it is positive, negative, zero, or undefined. Furthermore, when this lesson is over, you'll be able to explain mathematically how a slope is classified into one of those categories based on the value, because you will be able to show the computation that arrives at either a positive, negative, zero, or undefined value. Let's begin by looking at four different set of axes and four different lines to classify their slope. This line has a positive slope. Notice its angle. If we move from left to right, going across our screen, we are going uphill. It leans to the right. Let's look at this blue line. This blue line has a negative slope. If we keep the same idea of moving from left to right, we can see that this blue line is going downhill. This orange line is a horizontal line. It's perfectly horizontal, and its slope is 0. Finally, if we have a perfectly vertical up and down line, the slope of a vertical line is always undefined. In a few minutes, we will talk more about what it means to be undefined from a mathematical standpoint, but here you can see the four different possibilities for any line. Our red line, lines that lean in that direction, will always have a positive slope. Lines like our blue line that lean in that direction will always have a negative slope. Horizontal lines like our orange line will always be a 0 slope. And vertical lines like our green line will always have an undefined slope. Let's look at another way that we can remember the differences between a positive, negative, 0, and undefined slope. And since we're talking about slope, we're going to use a snow skier analogy. Let's begin by looking at our positive slope. If we put a skier on this slope and try to move from left to right, that skier is not going to be able to just go up that hill without putting any work to it. He's going to have to put energy into that, either walking himself up, shuffling himself up, or taking the ski lift. Either way, it's going to take a positive input of energy for him to go up this hill. Now let's look at the negative slope and put a skier on this mountain. If we put a skier on this slope and try to go from left to right, he's very easily going to just shoosh down that hill and not have to do any work into that. That's going to be a negative energy input. That is a negative slope. Let's continue to move along, and let's look at our 0 slope. If we put a skier on this slope and try to move from left to right, he's not going anywhere. There is a 0 slope. Those skis are not going to move. And finally, let's look at an undefined slope and put a skier on that and see if we can find a way to help us remember how that's going to work. If we put a skier on that slope, he's going to come down that thing so fast because it's straight up and down and vertical, he's going to be undefined when he gets to the bottom. That's how you can remember that a vertical slope, a vertical line, has an undefined slope. Let's look at our first example of how to compute the slope algebraically so that we can get a better understanding for why slopes are positive, negative, zero, or undefined. In this example, we have a slope of a negative slope for this line, because if we were to put our skier on this line, that skier is very easily going to slide down that hill, shoosh, without having to do any work. So that's a negative slope. But let's refresh our memory on how to compute slope. The formula for slope is m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Let's look at the coordinates of each one of these points, put them into our formula, and find out what we get. For the point up here at the top, this point right here, our coordinates were -3, +3. This point has coordinates of +2, -1. And I'm going to put those coordinates into my formula. Now, one of the things that I'm going to do is I'm going to label my coordinates so that I can make sure they match up correctly with the things in my formula. So I'm just going to be arbitrary about this. I'm going to call this my x1 and this my y1, because our ones have to go together. And this will be my x2 and my y sub 2. And now I can put those into my formula. Y sub 2 is -1 minus y sub 1, which is 3. Y sub 2, y sub 1. Now I'm going to put x sub 2 and x sub 1 into the formula. X sub 2 was 2, x sub 1 is -3. Now I want to point out something important here. Notice, even though this was a -3 here, I still got to keep this minus sign, and I just have my negative inside my parentheses with my 3 so that I can remember that I am subtracting a -3 from here. And we know that subtracting a negative is the same thing as adding a positive. So when I work this out, I will get -1 minus 3, -4 on top, 2 plus 3 is 5 on the bottom. So the slope of this line is -4/5. Now the question can be about that negative sign. The numerator we can just leave as -4. But here's what I want to do. I would like to redo this problem, and we'll switch our coordinates and see if we can get the same answer if we pick different ones to be our x sub 1, y sub 1, and x sub 2, and y sub 2. So here's the same situation. Same graph, same formula, same points. And I've written down over here on the top right to remind us that we got -4/5 when we allowed this point to be our x sub 1, y sub 1, and this point to be our x sub 2, y sub 2. But now we're going to switch that up. We're going to let this point be x sub 1 and y sub 1, and this point be x sub 2, y sub 2. And now we'll put those into the formula and see if we get the same thing. So we have 3 minus a negative 1. Remember, even though this is a minus sign and that's a negative, we still got to use both of those. So it's minus a negative 1 over negative 3 minus 2. We've got a minus a negative in our numerator. So just like before, that's the same thing as saying plus a positive. So what we'll have, 3 minus a negative 1, or 3 plus 1, is positive 4. And on the bottom, negative 3 minus 2 gives us negative 5. Again, that's a negative slope. Now we have to look at each one of these and refresh ourselves on what we know is true about mathematics and numbers and algebra, and are these the same? In our red example, the negative sign is on the numerator. In the green example, the negative sign's in the denominator. Well, let's keep in mind what we know about signed numbers. A negative divided by a positive gives us a negative number. A positive divided by a negative still gives us a negative number. So either way, these both are the same value, negative 4/5. That could be written as this with our negative out front, and we have a negative slope. And now we can see why, when the line is oriented this way, we'll get a negative slope, because we're either, if we start at this point and move over, our rise is going down. Or if we start at this point and go over to this point, we're having to go to the left, which is still a negative, so our run becomes negative. Either way, we get a negative slope. Now let's look at an example where we're going to get a positive answer. Again, we know this is positive from the examples that we did before with just the pictures. The slope is leaning towards, the line is leaning towards the right. And if we were to put a skier on this, that skier is going to have to go uphill, so he's going to have to put energy into it, which makes it a positive slope. Let's get the coordinates of our point. The coordinates of this point are negative 4, negative 2. And the coordinates of this point are 3, 4. And this is our slope formula. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So let's label our points. We'll make that x sub 1, that y sub 1, this x sub 2, y sub 2. It really doesn't matter as long as you keep your 1's and your 2's together. Putting them into our formula now. 4 minus negative 2. This is another one of those examples where we have the minus in our formula, but a negative for our number. We gotta have both. And our run, our denominator, is 3 minus negative 4. Keeping in mind that subtracting a negative always ends up in adding a positive. So 4 plus 2 gives us 6. 3 plus 4 gives us 7. That's our slope. A positive 6/7, which we knew it would be positive. We just needed to work it out. Now on the same screen, we're going to do this the other way. we're going to switch the order of our coordinates. We're going to make this one x sub 2 and y sub 2, and we'll make this x sub 1, y sub 1, and put those in the formula and see what we get. So we will have negative 2 minus 4 over negative 4 minus 3. That gives us negative 6 over negative 7. Well, what happens when you have a negative divided by a negative? Well, what you get is a positive answer. So that's really the same thing as 6/7. And our two slopes, regardless of how we computed those, gives us the same thing, a positive slope. Let's look at an example now where we know that we will get 0 slope for our answer, and look at why it's a 0 slope mathematically. Here's our horizontal line, and I've marked a couple of points to help us out here. One here, one here. And let's get the coordinates of those points. The point on the left is negative 3, positive 3, and the point on the right is 2, positive 3. Now, one of the things that I want you to immediately recognize is that they have the same y coordinate. Alright? And that makes sense if we're talking about a horizontal line like we have here, because we never go up or down. That's important to remember. If we never go up or down and we only go straight, there is no rise. Let's go ahead and put it into our formula and see how it works out. We'll call this x sub 1, call this y sub 1. This is x sub 2 and y sub 2. Now, one of the things that I haven't mentioned as we've been going through all of this is notice how I am labeling my points so that I know that I put them into my formula correctly. Alright, y sub 2 is 3, y sub 1 is 3, x sub 2 is 2, x sub 1 is negative 3. 3 minus 3 is 0. 2 minus negative 3, that's the same thing as adding a positive, is 5. I just got a 0 slope. Now, just for the sake of illustration, we'll do it the other way. We'll let this be x sub 2, and this be y sub 2, this be x sub 1, and this be y sub 1, and see that we get the same thing. And honestly, when we do this, it should be clear that we will, because we're still going to say 3 minus 3, and now we're saying negative 3 minus 2. 3 minus 3 here on the top is still going to be 0 over negative 5. And 0 over anything is always 0. The important thing to remember here is when you have a horizontal line, there is no rise. When we think about slope being rise over run, there is no rise in a horizontal line. There is no rise. Now, keep that in mind as we do an undefined slope. If we continue to think about slope as rise over run, and we look at our vertical line, here's a point, here's a point. There is no run. It doesn't move from left to right. So the bottom of our formula will give us a 0 if there is no run. And you can't divide by 0. anything divided by 0 is always undefined. But let's look at that from a mathematical point just to see it in action. Here's the coordinates of our 2 points. The top point is -3, 3, and the bottom point is -3, -3. I'm going to let this be x sub 1 and this be y sub 1. This will be x sub 2, y sub 2. Let's put it into the formula. -3 minus 3 over -3 minus -3. Subtracting a negative is the same thing as adding a positive. So -3 plus 3, those are additive opposites. They are inverses. We're going to get 0 in our denominator. So it really doesn't matter what's on the top, but we know it'll be -6. Because we have this 0 in our denominator, this is now undefined. And the same thing will happen even if we switch the points, because there is no run. It doesn't change horizontally, so we will always get a 0. So in review, if our line is going uphill or leans to the right like this, it's a positive slope. If our line is going downhill or leans to the left, it's a negative slope. Horizontal lines have a 0 slope, and vertical lines have an undefined slope.